There are a few things that are required to plot a graph. Of course, the first thing is your graph should have a title. The second one is the axis must be there, because we know that the axis is made up of a x-axis and we have the y-axis too, which our y-axis is the vertical axis and the x-axis is the horizontal axis. Okay? Alright, so the next one is, after having your axis, you must have a scale for your axis. The scaling of your axis is what determines the numbering of such axis. Okay? And the numbering is what we refer to when we're talking about the calibration of the axis. So the scale and calibration, the scale determines how you calibrate it. Okay? And the last but not the least, required, not that after having it, it means you have graph, but it means that you can have a successful plot. The table of values. Okay? Now let's take a look at each of these things as it were. So let's say we have a graph sheet given as this, or what a graph look like. Okay? So now when you are plotting your graph, few things are very important, which we tag requirements for your graph to be set to be in good shape. Okay, firstly, your graph must have the title. Okay, so the title, of course, is something of the form of graph of, because the equation you have here, in most cases, you will be given in the question. So it's the question that gives you the equation tag for the graph of. Of course, that should be the title of your graph in any case. So, the second one, like I have stated earlier, is the axis. Okay, so now for the axis, we're talking about the y-axis and the s-axis. Okay, so now if we have the y-axis and s-axis given as this, we can comfortably then do the calibration. Talking about the scale and the calibration of the axis. Okay, so for the calibration, it means the way we number the axis. Okay, and the scale means the measure with which we do the numbering. Okay, so now when talking about the scale, for instance, if you use your ruler to measure from ear to ear, you discover that's on your own graph. In your graph book, you discover it's 2 centimeters. Okay, so that's why if I want to use a scale of 2 centimeters representing 1 unit, that means this place is going to be 1, this is going to be 2, this is going to be 3, okay, and so on and so forth. And to the negative side of the y-axis, that means I have a -1, -2, -3. Okay, so and so on and so forth. Okay, so now, but if I decide to use 1 centimeter to represent 1 unit, that means I have 1. That means this place will be 2. This place is going to be, we have 1. We have 1. We have 2. We have 3. And we have 4. And so on and so forth. We have 4. And we have 5 here. That's if I'm using 1 centimeter to represent 1 unit. And as a matter of fact, for the sake of clarity, you can always check. You can always check to be sure that what we are talking about is correct, in that you bring a ruler here to check. You discover that the first first 5 boxes, if you measure them together, is 1 centimeter. So which fall to where the first line is, and the same thing goes for the other one. So that's why we can say conveniently that 10 boxes measure is 2 centimeter. So in your scaling, for instance, the scaling that you have decided to use here, we have a scaling on x-axis. Let's say we say 2 centimeter represents 2 units. By that, it means we have our 2 centimeter to represent 2 units. So if we say 2 centimeter represents 2 units on y-axis, that's why we have each unit to have 2, 2, 2, 2, 2, 2, and going upward is in 2s. That is, if you measure the 2 centimeter there, is 2 units. Okay, that's that. The last but not the least is the table of values. You need your table of values for you to be able to do plot your graph. You need your table of value to be able to plot your graph. Of course, you have your table of value as, of course, whatever value that result from the equation that you are given. Is the equation that will determine that eventually. Is the equation that you are given that determine what that value, those set of value will be. Because the value you have will be your coordinate. The value you're going to have there will be your coordinate that you're going to be plotting in your graph book. Now, let's take a look at a good question here. We want to use a graphical method to solve this simultaneous equation. So if you're given something like this, and you have to use graphical methods to solve it. You have to use graphical method to solve it. What you simply do, number one, you take a range of value of x. 3 values, in fact 2 in some cases is fine, but 3 is better to ensure a strong and accurate graph that is not going to be by any measure or by any dimension tilted away from the perfect line it's supposed to be. So we pick 3 points. Yes, you can actually pick any value. You can pick any value. In this case, I pick -3 to 3, but you can pick any value. You can decide to pick from -2 to 1. You can decide to even pick -5 to -2. Or, so at least 3 points. If you want to make it to be more than 3 points, it's fine. It's fine. But whatever it is, just make sure it's up to 3 points that your range of value includes. Okay? For those that don't understand this will make a little more sense. So you pick the first equation, which is what you have here. Of course, for the equation, we start by putting the value of x. You know, we say we pick a range of value of x -3 to 3. Like I said, you can pick any one. Because of the way this graph is, whatever you pick, what you just need to draw is a long straight line. After you have gotten your point, you understand what I'm saying as we progress. So when x is equals to -3, of course, you put -3 in the equation, and you have the respective value of y. which is going to give us y equals to 0.5. So we have a point. That's when x is equal to minus 3, our y is 0.5. So now let's proceed to the next value when x is equal to 0. When x is equal to 0, that means 2y minus 0. You know, in place of x here, you have to put 0 there. Okay? So that's 2y equals to 4, and that means our y equals to 2. Okay? So that means we have another value, that's 0,2. And when x is equals to 3, when x is equals to 3, what you do is you put the value of x same way in place of x in the equation. Okay? So after putting that, you have 2y equals to 4 plus 3. Okay? So that means 2y equals to 7, which you can write your y to be 3.5. So we have another point. That's 3,3.5. Now, when we are writing this point this way is generally in a coordinate system, when you are writing a point, yes, which is made up of two coordinates, yes, the x and y coordinates. So we write it in this is the general form of it, x, y. So what you have here first is your value of x. What you have here next is your value of y. Okay, so now our table is done. Okay, so this is the first table for this equation. So you can see when x is equal to 3, our y is equal to 0.5. When x is equal to 0, which is here, our y equals to 2. And when x is equals to 3,3.5, that's x equals to 3, our y equals to 3.5. So that's what we have just done there. So now we go for the second equation, because we're going to plot the graph for the first and the second equation. So from what you have here for equation 2, which is 2y plus x equals to 6. So what you do is you put when x is equals to minus 3 the same way, because you replace x by minus 3 and you solve your the resulting equation. You solve it further, and you have your value of y. Y is equals to 4.5. And when x is equals to 0, okay, so your y is going to be 3. Of course, the third one, when x is equals to 3, you find your value of y. Don't forget, this x is equals to 3, what we have simply done here is to replace the x here by the 3. That's why you have this. Okay, so from what you have there, that means 2y equals to 3. And then from what you have there, you say your y equals to 1.5. So you have the third point. Okay, so that means we have our table 2. Don't forget, for the first point, this is the point, and which is the same thing as this. Okay, and for the second one, we have this, which is the same thing as this. Okay, for the third one, you have this, which is the same thing as this. So eventually, you have your two tables. What are the two tables? We have the first table here and the second one here, which this belongs to this equation, and this belongs to this equation. So the next thing is to plot those points into. Now that we have our table, we have our table of values already, so it's time for us to plot the graph. Of course, don't forget, we're actually trying to solve the simultaneous equation using graphical method. Okay, so the first thing that we need, of course, is our title, which, like I said earlier, is going to comprise of the equation that you are plotting the graph for. The next thing is for us to bring out our table. But before we even bring out our table, let's check out our axis. Okay, so we have the y-axis, and we also have the x-axis drawn, which you are supposed to use your ruler to draw. And because of our table, the nature of what we have in our table of values determine what our scale will be So let me bring out the table again, the table that we have already derived. Okay, so for this equation here, we know that this is the table. Okay, so for the second equation, because I'm saying this because you need to consider the two values, set of values you have when you are plotting more than one graph. I mean, you are making more than one plot on a graph sheet. Yes, you should consider the two tables for you to choose an appropriate unit that will be suitable for the two tables. Okay, so now for the other table, if you have this, of course, you agree with me that this table is for this equation. Okay, it's for this equation. So if you look at it very well, we can easily pick an appropriate unit. In which case, if you look at your S-axis here, okay, you can see the values are few. Meanwhile, whatever you're drawing, you should give a room for you to have something big. Okay, so that's why I'm thinking we should just use a 2 centimeter to represent 1 unit. Okay, that's for our x-axis. For this axis, 2 centimeter represent 1 unit. Okay, so if that is the case, and you also know that by our 2 centimeter, it means we are counting 10 inner boxes. That's from here. If you check it very well, we have already explored this when I was giving you the introduction to the graph. Okay, all right. So from what you have there, you can just go ahead with that. Looking at our x-axis, we can do the calibration. So you can see, so that's 2 centimeter mark, representing 1 unit. So let's do it for the positive side and for the negative side. Okay, so we have our X label there. Okay, so the same thing now, let's put the values for the X. Okay, 1, 2, that's what I mean by 2 centimeter representing 1 unit. So for each calibration is 1 unit value. Okay, so we have that. For the negative side too, we put that. Now let's check out our y-axis. Looking at the values that we have there, this is the value we have for y. We want to choose a scale that will be suitable. Of course, it's fine for us to choose 2 centimeter to still represent 1 unit. Okay, so if we're choosing that, we can simply just calibrate it straight off like that. We calibrate it. Okay, you can see. Okay, let's plot the graph right away. Before we do the plotting, of course, we know the title comes first, which is the graph of the equation that we're trying to solve simultaneously. Okay, so the next thing is for us to put up our axis. For the y-axis and for the x-axis. Okay, now the next thing is for us to determine the scale that we are going to use. Meanwhile, to consider the scale, we have to check our tables. Okay, so now let's take a look at table 1. For table 1, of course, you agree with me that this table belongs to this equation. Yeah, it belongs to that equation there. And we can check out table 2, which we also agree with me that is for this equation. Okay, So from what you have there, you have the table, and we need to determine our scale for x-axis. To determine the scale for the x-axis, all we just need to do is to check out our point. Okay, so for x-axis, if you look at it very well, we have this, and then we also have this for x-axis. So suitably, it is convenient for us to just use 2 centimeters to represent 1 unit. This is what I mean by that. On x-axis, of course, we choose for y-axis 2 centimeters to represent 1 unit. This is what that implies. So on the x-axis, we have the calibration, and send there. Can you see? Okay, so that's 2 centimeters. So let's do the numbering of the axis for us to see the implication of what we are talking about. Okay, you can see the negative side of the x-axis. Okay, so that's that for the calibration of x-axis. Now for y-axis, if you want to determine the accurate scaling, if we are determining that, of course, the first thing we have to check is our axis. The set of value that we have there, 2 centimeters to represent 1 unit will be suitable for our y-axis. Because looking at our value, so if you're using that, by implication, it means we'll be having a calibration. Okay, that's the calibration, while we get it numbered as appropriate. The negative side too. Don't forget to put your 0 mark. In any case, it's very, very important. The 0 mark. All of them have a common point for 0. So that's where the 2 axes meet. And that's the origin of the, either you're going towards the positive side or negative side of the axis. The next thing is to start plotting the points. Starting with the first equation to plot the graph. Okay, so if we're starting with that, that means we first of all pick the first point. That's -3 and 0.5. That's when x is -3. You check the axis x. This is when you have -3. 0.5, of course, on our y-axis, 0.5 will be somewhere here. So what do? You trace the line from that point. You trace it. So if you trace it, where they meet, it's where we have our first point, which is going to be there. Now, taking a look at the second point, that is, when x is equal to 0, which is here, y is equals to 2, which is here. So obviously, the point where they meet is that point, and that's where we're going to be having our point. And the last point, which is 3 and 3.5. You look for where you have 3 on your x-axis. And 3.5 on y-axis. That's here. So you trace it. You trace it. Where the two lines meet is where you have our point. So, once you have done that, the first thing is, of course, you use your ruler to join the. So, once you bring your ruler in, then you draw the line. You join the line. You have the line for the first graph. So the same thing you're going to do for the second graph on the same axis. So you trace out the first point, that's -3 and 4.5. -3, 4.5. And then you have 0 and 3. Okay. And we have a 3 and 1.5, which, of course, with your ruler, you can conveniently draw the line. You can see, it's very important. And make sure, in any case, your line should extend beyond. You can see they extend beyond the last point. So don't just say that because your point stop here, then your line to stop there. No, it should extend beyond the point. You can see, they all extend beyond the point. So that is our graph. Now let's solve the question. What will then be our answer? Because very simple. What you just need to check is where the two lines meet. Look at it here. The two lines, they meet here. Can you see? So if you have gotten where they meet, then you trace it out. The coordinates of that meeting point. So where the 2 points meet, because if you trace it down, you can see it falls on 1 on the x-axis. If you trace it to the left, that's towards the y-axis. You see it meets at that point, because that place you can 2.5. That place is 2.5. You can conveniently say our x value is 1 and our y value is 2.5. Let's take a look at